Let's explore logic gates, specifically focusing on exclusive gates. We will discuss the XOR and XNOR gates, their symbols, and their basic functions. Here is the XOR gate, also known as the exclusive or gate. The symbol for the XOR gate is a plus sign inside a circle. The key characteristic of an XOR gate is that its output is high or 1 only when its inputs are different. Let's examine the truth table to understand this better. When input A is 0 and input B is 0, the output Y is 0. When A is 0 and B is 1, the output Y is 1. When A is 1 and B is 0, the output Y is 1. Finally, when both A and B are 1, the output Y is 0. As you can see, the output is high only when the inputs A and B are different. The Boolean expression for the XOR gate is Y equals XOR B, where the XOR operation is represented by a plus sign inside a circle. This expression can also be written as A inverse multiplied by B plus A multiplied by B inverse. To implement an XOR gate, we need a combination of AND, OR, and NOT gates. Therefore, the XOR gate is a combination of basic logic gates. Now let's take a look at the XNOR gate, also known as the exclusive NOR gate. The symbol for the XNOR gate is a circle with a dot inside. The defining feature of an XNOR gate is that its output is high or 1 only when its inputs are the same. Now let's understand this using the truth table. When both input A and input B are 0, the output Y is 1. When A is 0 and B is 1, the output Y is 0. When A is 1 and B is 0, the output Y is 0. Finally, when both A and B are 1, the output Y is 1. As you can see, the output is high only when the inputs A and B are identical. The Boolean expression for the XNOR gate is Y equals XNOR B, where the XNOR operation is represented by a dot inside a circle. This expression can also be written as A multiplied by B plus A inverse multiplied by B inverse. The XNOR gate has a complementary relationship with the XOR gate. Specifically, XNOR is equivalent to NOT XOR, meaning the output of an XNOR gate is the inverse of the output of an XOR gate for the same inputs. Let's explore some applications of the XOR gate. First, in encryption, XOR gates are used in cryptographic algorithms for data security. Second, as a half adder, an XOR gate can perform binary addition without considering the carry input. Third, it can act as a controlled inverter, where the signal is inverted only when the control input is high. Now let's explore a few applications of the XNOR gate. Firstly, it functions as an equality detector, comparing two bits to determine if they are equal. Secondly, it can be used as a parity checker, for error detection in data transmission. Finally, it can be employed in code converters such as in binary to gray code conversion. Let's summarize the key differences and applications of the exclusive gates. The XOR gate produces a high output when the inputs are different, while the XNOR gate does so when the inputs are the same. Key points to remember include that exclusive gates are fundamental components in digital logic. The XOR gate is useful for encryption and addition, while the XNOR gate is useful for comparison tasks. Both the gates have a complementary relationship, since XNOR is just the inverse of the XOR gate. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.